Okay, so here's what we're going to do. We're going to measure the position of each of the cards. Everything okay?
Yep.
We're going to measure the position of each of the cards. Which card is first, second, third, fourth, fifth, sixth, seventh?
Okay.
Okay. In the deck we have now, unshuffled, the card in the first position is labeled 1.
1, 2, 3. Yep.
Okay.
Second is 2.
Yep, second is 2.
So.
Then what we're going to do is we're going to take the difference between the numbers on the successive cards. So the difference between card 2 and card 1 is just 1.
Okay.
And we're going to do that all the way through until the end when, is this minus 51 on camera?
Yeah.
Okay. And if any number is ever less than 0, we're just going to add 52 to it to make it positive.
Okay.
Okay. So we're always going to measure the difference as being between 1 and 51, I guess.
Okay.
And then we have a list of numbers here, which is in green. All right, you see that?
Yeah.
Then what we do in the next column over is we're going to measure how many 1s do we have? How many had a difference of 1? How many had a difference of 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to how many had a difference of 52.
Okay.
Of course, a difference of 52 can never happen.
Yeah.
Why not?
Because there's only 52 cards.
Okay. And then I do my Shannon entropy calculation. Actually, sorry, first I divide by 52 to make sure it all adds up to 1. Okay.
Okay.
And then I do a calculation with Shannon entropy, where I take the number here, times the log of that number. Okay, now the log of 1 we already found was 0. And if the number is 0, I make it 0. Okay, and then here's my Shannon entropy. Actually, my setup is wrong. You have to take negative of this, but I'll fix that when we do this for real. Okay.
Okay.
So it's a fairly complicated mathematical measure, but it's actually easy to explain for
Yeah.
cards. I just look at the differences. I look at how many are in each bucket, right?
Yeah.
Yep.
Of differences. Then I divide those by 52 to make the numbers add up to 1. So because they're essentially probabilities. What's the probability of being in that bucket? And then I take the probability times the log of the probability, add them up, and make it negative, which I forgot to do.
Okay.
But we start out at 0. So 0 entropy means perfect order.
Yeah.
And what would you say about our cards?
They're
That's-
probably in perfect order.
Yeah.
Right
They're
now.
probably in perfect order. Okay, so I'm going to take this computer away, and I want you to do one shuffle that you know how to do. Okay, but before you do that, let's get your shuffle on camera here. Okay. All right. So you've broken the cards apart.
Okay.
Okay.
Now.
However you want to do it. All right. So there's one shuffle. Okay. So put them together. All right. So what we're going to do off camera is we're going to write these numbers down, and we're
Yep.
going to see what our new entropy is.
All right. Okay.
Okay.